Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in today's lecture, we are focusing on this M1 paper that is popularly known as Paper 4. This is from the May-June 2024 series, and this is the first variant. So let's get started, and let me just note down the time. This is 10:46 p.m. that we are starting this paper. It's a walkthrough solution. So I think it should take around like 35-40 minutes to go through this. Let's look at the first question. The first question says, a car starts from rest and accelerates at 2 meters per second square for 10 seconds. It then travels at a constant speed for 30 seconds. The car then uniformly decelerates to rest over a period of 20 seconds. So there is 10, there is 30, that is 20. So altogether, that's 60. Draw the graph realistically. The red line represents acceleration. This 2 meters per second square, that is the slope. This is a flat line, zero acceleration. This is a negative slope, negative acceleration, also known as deceleration or retardation. Now, what we can do is that change in velocity over change in time is acceleration. Slope of this line is acceleration. V over 10 is 2. V comes out to be 20. So also label this thing as 20. And find the total distance traveled by the car. That's the area under the VT graph. This is a trapezium. These two are parallel sides. The length of the longest parallel side is 60. The length of the shorter one, the blue segment, that is between 10 and 40, which is 30. The height is V over here. The value of V is 20. That comes out to be 900 meters. That is the first thing. Now over here, before we get started, let me just talk a bit about resolution of forces. If I draw a right angle triangle, if I label the hypotenuse as F, the opposite as opposite, adjacent as adjacent, and I'm taking angle theta with the horizontal. So if I use sine, I'll be using opposite hypotenuse with respect to this angle, because opposite of theta is this length, the blue line. So sine theta is opposite over F. Therefore, opposite is hypotenuse times sine of the angle with the horizontal. Similarly, if I'm interested in the adjacent, so cosine of theta is adjacent over hypotenuse. Hypotenuse times cosine of theta is the adjacent. Why did I specify this thing first? Because in this particular question, whenever it's a question about equilibrium, it's a question about resultant, it's a question about inclined plane, and we'll soon come to an inclined plane, the very first thing that needs to be done is that resolve the forces. So along the horizontal, since you are taking this angle with horizontal, it will always be in terms of cosine, and the other one has to be in terms of sine. The components should include the original force. The original force is sandwiched between the components. Take care of that. It's not possible that the force is going this way, this is going this way, and then the sine theta is going this way. That is not possible. So now let's read the question. Two forces of magnitude 20 and F act at a point P in the direction shown in the diagram. Now keep in mind, the examiner talks a lot about it, that this first statement over here, this is valid for part A, this is valid for part B. It's for both of them. So now it says, given that the resultant force has no component in the y direction, calculate the value of F. What does it mean? That means the upward force and the downward force, they are adding up to 0. That means this is positive, this is negative. In other words, these two are equal to one another. So F is equals to 20 sine 60. I have used the exact value. This is the answer in the exact form. If you want to give in the exact form, or if you want to work in decimals, work in 4 significant figures so that the final answer is given correct to 3 significant figures. So part A is done. Now it says it is given instead that F is 10. Find the magnitude and direction of the resultant force. So now what I've done is that I've done 2 things. First thing, 20 cos 60. Let me write down this value. That is 10 Newton. 20 sine 60. This value is 17.32. But 17.32 is upwards. F is 10 Newton downwards. In other words, this is 7.32 Newton upwards. All good, all clear? So let me just change the color. I think I took horizontal to be red. So let me just change the color to red and change this color to blue. Okay, so now this is better. So it's 7.32. That is right over here. That goes over here. That's the overall resultant force in the y direction. This is the overall horizontal force in the along the x direction. So my resultant has to be in the middle. So apply Pythagoras theorem. Through that, change head to tail method. So this is 10 this way. This is 7.32 this way. That's how the triangle is fulfilled. Apply Pythagoras theorem. You find the value of r. And then alpha is tan inverse of vertical divided by horizontal. Vertical over horizontal, that is 36.2 degrees. Take care of the accuracy. Final answer, 1 dp. 2 questions are down. There is a lot of extra spaces, so no one has the right to complain about spacing. Usually, 99% of the time, it's more than enough. And then you have all the extra things over there, the additional pages at the end. Now it says a train of mass 180,000. So let me highlight this thing. A train of mass 180,000 kg ascends. That means it's going up. Ascends a hill, and the hill is like this, of length 1.5 kilometer, converted into meters. Incline at a very small angle, 1.5 degrees to the horizontal. So now again, the angle with the horizontal is given. Of course, we are not going to do it by what you call F is equals to ma, a question which is about work and energy. Then I use the different work energy principle scenarios, and I'll soon go over this. Then it says, as it ascends, the total work done. The total work done to overcome the resistance, work done against resistance, is 12,000 kilojoules. So that is 12,000 into 1,000 joules. You can also write it like this, or 12,000 into 1,000. This is joules. And then what else is there? The speed of the train decreases. So the speed of the train decreases from 45 to 40 meter per second. Now it's asking, find the work done by the engine of the train as it ascends the hill. Give your answer in kilojoules for 4 marks. Something very, very basic. Now, let me remove all this extra stuff from here, this thing, all this thing from here, and let me just change it into stroke eraser. Okay. Now, the very first thing is work done against resistance. This is given. So let me use a color over here, the purple color. That is this thing, work done against resistance. This is given. The second thing, the change in potential energy. The change in potential energy will be positive. Why? Because it's going up, it's ascending. So mass mg sine theta into distance along the plane. So change in potential energy is mg sine theta into distance along the plane. That's the formula I have used. Then change in kinetic energy, that is half m v square minus u square. Since v is smaller than u, since final is smaller than initial, naturally the change in potential, it's coming out to be negative. So change in potential energy, it's coming out to be negative because the speed is slowing down. 2 things are done. The third thing, that's the most important thing, that is this equation. That is work done by engine. Let me highlight it above. The work done by engine, that is equals to change in potential plus change in kinetic plus work done against resistance. Change in potential is positive. Change in kinetic is negative. Work done against resistance is always taken as positive. That is the placement of all the terms in this equation. Place things where they belong, and then you get this answer, 44400 kilojoules. This is the rounded off value. So that's how this question is done. So now let's look at question number 4. It says a car of mass, let me highlight this thing. A car of mass 1700 kg is pulling a trailer of mass 300 kg along a straight horizontal road. So this is a flat horizontal road. The car and the trailer are connected by a light extensible cable, which is parallel to the road. That's how the tow bar or the cable, things like that. There are constant resistances to motion, 400 Newton on the car, and then 150 Newton on the trailer. And then it says the power of the car's engine is 14,000 watt. Find the acceleration of the car and the tension in the cable when the speed is 20 meters per second. A very simple concept. That is of F is equals to ma, and this is connected particles. So this is application of Newton's laws of motion, and it is about connected particles. And it's also about the concept of F is equals to ma. That is what we apply. So now what we do is that the way that I do it, some physics teacher, they do it in some other ways. So I have a difference of opinion with them. For the car, just make, first of all, you have to make a diagram. That is the engine force divided by speed. So we know that power is force into speed. Therefore, force is power over speed. That is what I've used over here. That is the engine. The car has an engine. The trailer does not have an engine. Otherwise, it won't be going all along with the car. There is tension in the cable from the perspective of car. This is in this direction. For the trailer, it's a pulling force. 400 Newton over here, 150 Newton over here. Make one equation for the car. Look at this thing. Forward force minus backward force is mass into acceleration. Forward force, backward force, mass into acceleration. For the trailer, this is the forward force, this is the backward force. Forward force, backward force, mass of trailer into acceleration. Add both the things, and what do you have? You have the system equation. So now that is how the connected particle is formed, the equation of the system. The tensions cancels out, and this is 700 minus 400 minus 150 is equals to 2008. A comes out to be this fraction. Leave the answer as fractions. Find the tension. This is the easy equation. T is 150 plus this thing, and this is what you get. This is the answer in the exact form. So there is no rounding off. This is exact, and this is also exact. So now just acknowledge either on the group. Let me first write something on the group. So till question 4, I have explained it, and just acknowledge on the group if it's all good, all clear. So now it's 10:59. What time did we start? Hold for a second. So we started at 10:46. And then the first stage, 1, 2, 3, and 4. So this is stage 1. It's a walkthrough video. And the time is exactly 11. So 14 minutes for this first stage. Not bad. So let's focus on the second stage. And if needed, there would be a third stage. Just to give you an idea. So 1, 2, 3, 4, and I think 7 questions. Let's see how it goes. So now, where is it? Okay, question number 5. It says a straight slope of length 60 meters is inclined at an angle 12 degrees to the horizontal. So let me get my highlighter ready. First of all, a straight slope of length 60 meters is inclined at an angle 12 degrees to the horizontal. Now, a lot of people, it so happens that when they hear the word straight slope, they think it's straight like this. No, straight slope means it's like this because the angle is given of 12 degrees. So it's a good idea just to draw a small diagram so that you remember exactly what you are dealing with. So this is 12 degrees. A bobsled starts at the top and of the slope with a speed of 5 meters per second. The bobsled slides directly down the slope. First part, it's a smooth inclined plane. There is no resistance. Find the speed when it reaches the bottom. So now let me just erase this thing. Hold for a second. Precision eraser. That's this thing. So now If this thing is sliding down, this weight component is mg sine theta. Along the component, mg sine theta. There is no resistive force, so it's accelerating down. So resultant force is mass into acceleration. M cancels out. G is 10. Sine 12 is equals to A. This is 2.079. This is 4 significant figures. If they were asking to round it off, then I would round it off to 3SF. Then the next part, no, the same part after this, find its speed when it reaches the bottom of the slope. Now it's basic kinematics. We have the initial velocity, we have the acceleration, we have the distance. V square is u square plus 2as. So this is the answer. This is given to 3 significant figures. A lot of space. The next one, it is given instead. So now everything is the same. Again, let me emphasize on this because nowadays people do make these mistakes. I don't want you to be making mistakes. This first paragraph, this is for both the parts. This is for part A. This is also for part B. It is given instead that the coefficient of friction between the bobsled and the slope is very small, 0.03. Find the time it takes for the bobsled to reach the bottom of the slope. Now, it's always a good idea to draw a diagram. That is mg sine theta, F max x parallel to the surface. F max always opposes motion. R is mg cosine theta. Acceleration is downward. F max is mu r. R is mg cos theta. So now what I can do is that, let me erase this thing. I'm not doing the working or calculation over here at this stage. F max is this thing. Then I am focusing on this. Let me choose a red marker. This is the weight component downward. There is a negative sign. Then there is F max over here. This difference is what? That is mass into acceleration. Now, have you observed that there was no mass given? Why? Because it would eventually cancel out. So now there is m over here. And let me write over here. There is m over here. There is m over here. There is m over here. So if I take m common like this, and this is g sine theta minus mu g cos theta. And let me just shift this thing over here. And let me write m over here. And let me draw a circle around it. So now these two m's, they cancel out. So when these m cancel out, there was no need of m. So now plug in the values. What values do we have? We have g, which is over here, sine of 12 degrees, which is over here. Then there is mu, which is 0.03. Then there is g, which is 10 over here. Then there is cos of 12 degrees. At this point, you would use a calculator. You're not a clerk, you're a student. You are here for the analytical process. You write everything down, and then you plug in the calculator, and you get this value. This is 4, 5 significant figures. The rule is at least 4 SF. So 4 SF is also good, 5 SF is also good, no issue, but don't exceed. Now they are asking this time, find the time. So I have, again, kinematics, initial velocity 5, acceleration is this thing, S is this thing. Now compare it with the previous one. When it was a smooth slope, acceleration was 2.079. When it's a rough slope, the acceleration is lesser, which is natural. Now, they're asking for the time. So some people, they use this equation. And I'm not very fond of that equation because that involves a quadratic. That is S is equals to ut plus half at square. So some people, they would write 60 us5t half into 1.7856 into t square. And then you find the values of t. But I prefer, this is what I prefer. What I prefer is that work in simple terms. That is, first use this equation, find the value of v, and then the next stage, use v is equals to u plus at and find the value of time. So I prefer using this equation. That is my way. All good, all clear? So again, this was a very, very basic question. That was question number 5. Now question number 6, again, when we study M1, we study with P1 and P3. So only knowledge of P1 is assumed. That is about basic differentiation. That is about integration. That is about limits. That is about maxima, minima. For example, if they ask for maxima or minima of something, so that means the derivative of that something should equal to 0. That is the rule. And we will use that thing over here just right now. So now it says a particle moves in a straight line starting from point O. The velocity of the particle at time t seconds after leaving O is v meter per second. This is the equation given, where k is a positive constant. The maximum velocity of the particle is 4.5. Show that k is equals to 10. Now, this was slightly tricky question. It was slightly tricky. Why? Because I'll just tell you so. Because of the way the working is done. So now it says the first thing, v is given. Let me highlight this. V is given. Acceleration is derivative of velocity, which comes out to be this. Simplify, and that is acceleration over here. For maximum velocity, derivative of whatever we are talking about should equal to 0. In other words, acceleration equals to 0. So this is k over 2 root t minus 2 equals to 0. You get k is equals to 4 root t, or you can also write this thing that k over 4 is root t, or t is equals to k square over 16. You can also use this, which I'll use in a short while. Now what I'm doing is that if I use this thing, now plug in k is equals to 4 root t and v is equals to 4.5 in velocity equation. There is no other thing as such. And the information is given about velocity. So the velocity equation is this. And when I plug it in, I have written in the square root form. V is 4.5. This negative 8 taken to the other side, that's 4.5 plus 8. And this k is written as 4 root t. Root t is there, minus 2t. 12.5 is 2t. T comes out to be 6.25. Now, k is dependent upon t. So k is 4 root 6.25, 4 times 2.5. Therefore, k comes out to be 10. And that is exactly what they were after for 5 marks. Yes, it's definitely worth for 5 marks. Have a good look at it. Of course, when I'll upload the video on YouTube, you can always pause, take a screenshot, jot it down in your register, and that's the way to do it. Now, I have also done this thing in an alternative way. That is this way over here. If I take this thing over here, that is t is k square over 16, I can also plug this thing directly. So now v is 4.5. This negative 8 goes on the other side, becomes positive. K is k, and instead of root t, what have I written? K over 4. And instead of t, what have I written? K square over 16. So k, hold for a second, root t is k over 4. So that is what I've plugged over here. So let me just highlight using a color. So root t is k over 4. Root t is k over 4. And similarly, a t is k square over 16. T is k square over 16. Got the idea? That is the working that I've done. And when you solve this, you find the value of k square as 100. Therefore, k again comes out to be what? So k again comes out to be 10. So any which way. So now definitely it was worth 5 marks. It was slightly tricky, little bit difficult. Verify, this is easy. Verify that v is 0. When t is 1, t is 16. Verify, so just plug in. You don't have to solve. When t is 1, plug it in over here. The value of k is 10. The value of t is 1. This comes out to be 0. When t is 16, value of k is 10. Plug in 16, plug in 16, simplify, that's 0. So these are the two turning points. When v is 0, that means the car or the particle, whatever that is, that comes to instantaneous rest, right? Now, why do we need it? We need it because, let's say, the particle was at O. It went to this thing. When t is 1, v is 0. Then it will turn around. And it will turn around and go in this direction. When t is 16, v is 0. And then it will turn around in the other direction. That's how it goes. So what we do is that if we draw this graph on a graphic calculator, part of the graph will be below the x-axis and part above the x-axis, something like this, just to give you an idea. So this is 0, this is 1, this is 16, This is below x-axis. This is above x-axis. So it's about integration. It's about limits. So you have to integrate it separately. That is why this is giving you the hint. And this hint is now related with this part. Find the distance traveled by the particle in the first 16 seconds. So don't get excited. Don't just integrate between 0 and 16. That would be definitely wrong. So the first stage, that is from 0 till 1, integrate the velocity function. Don't have to worry about c because the limits are there. And this answer comes out to be -7/3. That means this is area under x-axis. So therefore, discard negative sign or take the modulus value. Then the second part, that is from 1 till 16. Integrate, plug in the limits. That's all the algebra for you to do because you know your P1 very well. You people, some of you might be studying P3. So this answer comes out to be 45. So this is -7/3. Take the modulus, 45, add it up. This comes out to be 142/3. That is the distance covered. Again, this is 1 plus 5, 6 marks. And then 5 marks for the first one. So 11 marks out of 50. So that was a tough question. So now 2 questions that we do. Hold for a second. Last one is left. So we started at 11. And now this is 11, 13. This is a walkthrough solution. So we did question number 5, question number 6, not bad. And then we will move to question number 7. Let's see how much that last question would take. So now let's go back. And we're already on the good notes. Okay. So now the last question, and you very well know what would it be about. It would be about momentum for sure. And a little bit of momentum, very little of momentum, and more of gravity and everything. So maybe that's about the changing times. Maybe they are focusing less on momentum. A particle P of mass 0.2 kg. So let me highlight this. A particle P of mass 0.2 kg is projected vertically up from horizontal ground with a speed of 25 meters per second. Show that the speed of P when it reaches 20 meters above the ground is this much. The answer is given. Again, it's kinematics. So what do? We have u, we have the distance, we have acceleration negative because it's going up. Apply v square is u square plus 2as. Without any calculator, you can comfortably get this answer. That is the first thing. Now it says the momentum part is now here. When P reaches 20 meters above the ground, it collides with the second particle Q, and the mass of this particle is 0.1 kg, which is moving downwards at 20 meters per second. And then it further says that P is brought to instantaneous rest in collision. Find the velocity of Q immediately after the collision. Now what is happening is that when it reaches 20 meters above the ground, it has a speed of 15. It has a mass of 0.2. Q is coming down. It has a speed of 20 and mass of 0.1. So now momentum before collision is equal to momentum after collision. Mass, velocity, mass, velocity. This is P, this is Q, mass, velocity P, mass, velocity Q. So this is 0.2, 15, 0.1, negative 20. Take the velocity up to be positive. So the other one should be negative. 0.2 into 0 because it comes to rest, 0.1 into v, therefore v is 10 meters per second. That means Q is moving upwards. So let me write over here, this is Q. So what is happening is that this particle Q, it's moving upwards with 10 meters per second. All good, all clear? Now the next part, that is part C, and that's a long part. I think it's worth 4 or 5 marks. 6 marks, okay. So now it says, when particle P, let me highlight it. When particle P reaches the ground, it rebounds back upwards, directly upwards with half the speed that it had immediately before hitting the ground. Find the height above the ground at which P and Q next collide. So there is P, there is Q, and there would be another collision. Now, this is for 6 marks. So you have to think very, very analytically. And of course, one such question is always there, which will differentiate between the A stars and the A's and the A's and the B's. So of course, one question always has to be there. And usually it's one of the last questions. So now it says, find the height above the ground. Now, first of all, let's focus on P. So let me highlight P. Let's focus on P, no, the red color. When we are talking about P, at this point, what is happening? P has come to rest. It has an initial velocity of 10. It's going down and it's 20 meters above the ground. So velocity of P is coming out to be 20 meters per second when it hits the ground. And the time that it takes is 2 seconds for reaching the ground. So that is important. At the same time, what's happening with Q? So now Q has a speed of 10 meters per second. It's going up. Final velocity is 0. This is for reaching the maximum height. Acceleration is -10. So it takes 1 second to reach maximum height. This is for reaching maximum height. Now it's a property which I can take for granted, or I can do the calculation. That if I'm talking about Q, so if it takes 1 second, let me just use a marker. If it takes 1 second to reach the maximum height, let me get this thing clear. Okay, like this, like this. If it takes 1 second to reach the maximum height from 10 to 0, if it takes 1 second, then from 0 to 10, it will again take 1 second. Or you can say from 0 meter per second, if it moves for 1 second, it will reach a speed of 10 meter per second. And if it was moving at 10 meter per second, after 1 second, if it's going up, it will reach a velocity of 0. So this is just symmetrical. So now I have done it. I did not assume it. I want you to have a feel of it. I did it again. So now it's starting from 0, 10 meter per second square. That is the acceleration downward. Time left is 1 second. 2 minus 1 is 1. Therefore, it again has a speed of 10 meter per second. Next time, take it for granted. Next time, just use this value because it's a symmetrical rule that always happens. Now the scenario is this. They are now facing off with each other. Hold for a second. They are facing off with each other. P has reached up with half the speed at 10 meter per second. The speed of Q is this thing. And in 2 seconds, when it's going up, this is like this, and this was coming down at 10 meter per second. Now, how much time will it take? It's not necessary that they are attacking or facing off right away. This might be something like this. This is the ground. Let me draw the ground over here. So this is the ground level. And from the ground level, it is moving up. So it's moving up with 10 meter per second. That is coming down. And this distance apart, how much is that? That is 20 meters again. Why it's 20 meters? Let me emphasize that. This P was going all the way to the ground for 2 seconds. This one was going up like this and then coming up like this. That is the journey. So now this is going up. This is coming down. That is what is happening. Displacement of P, ut plus half at square. For P, acceleration is negative. And displacement of Q, that is ut plus half at square. This is positive. Why? Because this is moving down. Why? Because this is moving up. And then the total is, no, it's not necessary, and it is definitely not that they are traveling equal distances. So the total displacement is 20. T comes out to be 1 second. Just after 1 second, they would collide. If I work from the perspective of P, if I plug in this equation, this answer comes out to be 5 meters. That means it moves 5 meters up. If I work from the perspective of Q, after 1 second, it travels 15 meters. That means it has traveled 15 meters down. The total distance is 20 meters. So what is the difference? That is again 5 meters. So that was a 6-mark question, the last one. And I hope that's the last one. Yes, it is. So let me go up all the way. And let me write for this question number 7. 11:13, 11:21. Yes, it's a walkthrough solution. It's 8 minutes. So I think if I think realistically, even if I double it, so this is the timing for walkthrough solution. And if I do it by myself, do it yourself, DIY. So therefore, this 14 should be 28. And then this thing over here, 14 minutes. This is 13 minutes. This 13 minutes should be 26. This 8 minutes should be 16. So 28 plus 26, that's 27, 27, 54, 54 plus 16. That is 1 hour, 10 minutes, 70 minutes. I think that's more than enough. That is 70 minutes with all the explanation. So in 70 minutes, you can easily do this paper. And that's all from my side at Mathematics with Shahab Yaqub. Take care, everyone.